Welcome to the future of Triple E channel. I am Siddharthan. In the last video, we have seen the per phase equivalent circuit and phasor diagrams of synchronous motor. In this video, we will see about torque angle or power angle and also speed torque characteristics of synchronous motor. Before that, let's see some important points and let's derive the power and torque equation. The rotor speed in the synchronous motor is equal to the synchronous speed ns, which is equal to 120 F divided by P, where F is equal to frequency of AC supply and P is equal to number of poles. So, until the frequency of the AC supply changes, the speed of the rotor remains constant and equal to Rm of speed ns. It is to be noted that the rotor speed will be constant and equal to Rm of speed ns even when the load increases or decreases. In other words, the rotor speed remains synchronized with Rm of speed ns and it will be irrespective to the load torque. However, it is very important to note that there is a limit on this load torque that can be applied to the synchronous motor without losing this synchronism. To find out these limits, or in other words, to find out the stability limits, let's take the per phase equivalent circuit which we derived in the last video to find the power equation and torque equation. Vt is the per phase voltage and is considered as reference phasor, so angle is 0 degree. Ef is the EMF induced in the stator winding due to the rotor field flux phi f. The angle with respect to Vt is considered as del. This angle del is called power angle or torque angle. You will get the reason for the name in the end of this video. Zs is the synchronous impedance which is equal to Rs plus jXs, where Rs is the stator resistance and Xs is the synchronous reactance. The angle for Rs is 0 with respect to reference voltage phasor Vt and the angle for Xs is 90 degree with respect to reference voltage phasor Vt. So, the angle for Zs is also 90 degree with respect to the reference voltage phasor Vt. The per phase complex power S is equal to Vt into I star. Here, star is used to represent the conjugate, and this conjugate of current phasor I is used to conform with the convention that lagging reactive power is considered as positive and leading reactive power as negative. If you are not using this conjugate, then negative will be coming for lagging reactive power and positive will be coming for leading reactive power, which is wrong. If we are substituting the current and applying the conjugate, we will get the complex power S as shown here. From this complex power, we can find the real power P and reactive power Q. Please remember that it is only for single phase or per phase equivalent circuit. For three-phase synchronous motor, real power P is equal to 3 into magnitude of Vt into Ef divided by Zs into sin del. And reactive power Q is equal to 3 into magnitude of Vt into Ef divided by Zs into cos del minus 3 into magnitude of Vt square divided by Zs. As you can see, the real power P is directly proportional to sine of angle del. That's why del is called power angle. Similarly, torque equation can be substituted and equal to 3 divided by omega s into magnitude of Vt into Ef divided by Zs into sin del. As you can see, the torque T is also proportional to the sine of angle del. That's why del is also called torque angle. So, the characteristics of power and torque with respect to angle del can be drawn similar to half cycle of sinusoidal wave as shown here. It is important to note that we will get the maximum active power or maximum torque at angle del is equal to 90 degree. From this graph, we can tell that the synchronous motor can be loaded gradually up to the limit of Pmax or Tmax or del is equal to 90 degree, which are known as static stability limits in synchronous motor. That's why del is also called load angle. However, the synchronous motor tends to pull out of synchronism, that is at del is greater than 90 degree. This is because of excessive load torque. The field current of rotor can be increased and hence EF to develop high torque and to prevent the loss of synchronism. The physical significance of load angle or power angle or torque angle del can be understood from the diagram. We know that when a three-phase supply is given, the rotating magnetic field is created in the stator and rotates at synchronous speed ns, which is equal to 120 F divided by P. When load is applied to the synchronous motor, then the rotor will lax the stator magnetic field as shown here. However, there will be a magnetic locking between the opposite poles of rotor and stator. Due to this magnetic locking, the rotor speed Nr will also be equal to synchronous speed Ns. Here, this is the axis of stator magnetic field and this is the axis of rotor field. The angle difference between these fields is called power angle or load angle or torque angle del. If load increases, then this load angle or power angle or torque angle del increases. Hence, the torque of the motor also increases. However, due to this magnetic locking between the opposite poles of stator and rotor, the speed of the rotor Nr will be still equal to Ns, or in other words, it will be synchronized with Ns. It is to be noted that these good things will happen until this power angle or load angle or torque angle del is less than 90 degree, or in other words, within the stability limits. If load angle del is greater than 90 degree, then everything will be collapsed and synchronous motor will be unstable. So as far as del is less than 90 degree or within the stability limits, the rotor speed is equal to the synchronous speed ns. If the load torque increases, the motor torque alone increases and speed still remains constant and equal to ns. This is the main difference between the synchronous motor and induction motor. Since in induction motor, if the load torque increases, the motor torque increases and along with the speed decreases. So the speed torque characteristic of synchronous motor is a straight line and parallel to the torque axis as shown here. Okay, from the next video we will see the speed control methods of synchronous motor. You can download this PPT and PDF from the link given in the description of this video. If this video helps you, then please like, share and also subscribe the channel. Have a smile and have a good day.